Hello, friends. An exciting topic today, AI for the visionary. L is for LLMs or large language models. I am Dr. Sonali Tamankar, and this is the AI A to Z series. The unreasonable effectiveness of recurrent neural networks, written in 2015 by Andrej Karpathy, was one of the most fun articles I've ever read. Already then, recurrent neural networks could generate fake but plausible looking Shakespeare and algebraic geometry text. This made me feel like a kid watching a magic show. Then the Attention is All You Need paper came out in 2017 and had a tremendous impact. We talked about this paper cited over 200,000 times in G is for GPT or Generative Pre-trained Transformer. We also peeled back more layers in E is for embeddings and F is for foundation models. Embeddings convert words into vectors, and large language models learn from mountains of training data by doing a whole bunch of math. We have come a long way since then. Now we have LLMs that achieve outstanding performance on medical and bar exams and can solve math Olympiad problems at gold medalist level. So today we have many companies competing for spots on LLM leaderboards. There are proprietary and open source LLMs. The open source LLM parameters can be freely downloaded so that organizations can host these on their own infrastructure within their own firewalls without sending their data out. In fact, you can even run a quantized model on your laptop with tools like Olama. I list some of the leading models as of January 2026, both proprietary and open source. But this list will keep changing constantly. Okay, wait though, we don't typically have the same human who is a lawyer and a doctor and a math Olympiad gold medalist. Humans often work as teams of experts. This idea also works well for LLMs, and most of the current leading models are mixture of experts models. Instead of having one large monolith model, we have a neural network architecture that uses specialized submodels or experts and a gating network or a router that will dynamically send specific input to the most relevant experts. This way, only a fraction of the model is activated for each input, which gives us far better efficiency. This diagram is a simple abstraction, though real expert components are not literally single domain specialists like this, and the routing happens at token level, not at query level. Okay, in addition to the brilliant ideas and algorithms, it turns out there is another ingredient, emergence. So look at this figure showing how well models do at different tasks like math word problems and 8-digit addition. Now, I used to be a physics professor, and we always told our students to show their work. What if we ask the models to do the same thing? So this chain of thought and Scratchpad are techniques where you ask a model to think through the steps and show their work before answering. So now look at the difference between the black line and the blue line. Blue line is where the models are actually using these techniques. Now for small size models, in fact, the performance in fact degrades very slightly, but it's about the same. But as the models grow to a certain size, suddenly they seem to get it. And these techniques really help them, and their performance improves tremendously. So this is called emergence. So when the models develop new abilities like logical thinking, once they grow to a certain size, so they can follow instructions and think logically. So big models, large models can do things that small ones just can't. Like a butterfly that emerges from the chrysalis can suddenly fly. So LLMs have the brilliant algorithms and the architecture powering them, but it is also the scale that unlocks their intelligence. So, research continues into fascinating and innovative ideas. Large language models are great, but to me, it has always felt like words are narrow, limited funnels for ideas. We humans have an intuition, we have unconscious layers of thinking. So, we take a lot of information and process it without even putting it in words. Communicating an idea in words is often only the last step. So, an interesting approach is the looking at our whole world that is full of sights and sounds as well as language and words. And we will talk about this tomorrow in M is for multimodality. So the approach of joint embeddings represents all of this visual and textual information in the same abstract space. So I'll link some resources below for the cutting edge efforts like the VL-JEPA model that came out in December 25. This uses the transformer architecture with joint embeddings and only computes the word tokens when needed. So I see this as the equivalent of not fully spelling out each thought in our head in words. Okay, another interesting, very different approach from transformers is world models. For example, a state space model like Mamba. So state space models compute how states evolve. So as you are listening to this video, you might maintain a constantly updating internal state, a mental summary of this conversation. And as new inputs or new words come in, you might update this state but discard the raw data. A little while later, you might remember the key ideas, but not every single word. And then finally, as we give AI more of an ability to act in the world through agents, we want our LLMs to better support these agentic workflows. So increasingly, we are moving towards agentic LLMs, which are optimized for this. So these are just some of the innovations, and I'm sure there will be many more we'll talk about in our AI A to Z 2027 series. Some of these will blow up, some of these will die down. That's an exciting world. Okay, so our takeaways for today: LLMs develop emergent capabilities as they grow to a certain size, and there are many excellent proprietary and open source LLM models available today, with new ones coming up constantly. And beyond the established attention-based transformer architecture where we predict every token, there are constant innovations, and we'll undoubtedly see more. So tomorrow we'll get into M is for multimodality. We'll talk about images and words and way more cars. See you then. Bye.